Hi, this session is on some practice test questions on our topic on right angle triangles, which includes Pythagoras, trigonometry, and similar triangles. Okay, for our first question, it asks us to calculate the area of the blue square and use this to find the length of the hypotenuse. Okay, and it's number 4 there and number 2. So have a go first with all the questions we do and see how you go. Okay, so to find the area of the blue square, we have to use our Pythagoras skills, and we know that Pythagoras Theorem states that the sum of the two smaller squares, so if we just do those ones, if we add them together, the sum of these two squares is equal to the sum of the larger side. Okay, and we're squaring the lengths. So we have to make sure we square the lengths. So I'll go 4 squared and 2 squared. Okay, and that'll give me the area of each of these squares. So 2 squared is 4. So that has an area of 4. And 4 squared is 16. Okay. And now all I've got to do is add these two smaller squares to give me the larger square. Okay. So 16 plus 4 is equal to 20. So the area of that blue square is 20, and we can just say units because we don't know what the units are. And that's the area of the blue square using our Pythagoras skills. So the sum of the lengths of the smaller sides is equal to the larger side, the hypotenuse. Now, to work out the length of the hypotenuse, you could use that formula, c squared equals a squared plus b squared. And we can see we've got our two smaller sides here, we substitute in there. But we've actually already started this process. We have squared the smaller two sides and gotten a square of 20. So all we've got to do to find the hypotenuse is square root 20. And that's it. Now we can just round off this to get an approximate answer. So the square root of 20, I'll just put it into my calculator, is approximately 4.3, we just say units. Okay, and we found the length now of the hypotenuse. For our next question, it asks us this. The following numbers represent the side lengths of a triangle. And we have 6, 8, and 10. Is this triangle a right angle triangle? So have a go first and think about it, and we'll do it together. Okay, so we need to work out if 6, 8, and 10 make up the sides of a right angle triangle. Okay, so we know a right angle triangle has a 90-degree angle there, and the opposite is the hypotenuse. Now we have to remember the hypotenuse is the largest side or the longest side. So longest side. So if we have a look at these numbers 6, 8, and 10, which is a larger number? Well, 10 is. So I know that with this right angle triangle, 10 must be the length of my hypotenuse because it's the longest side, which means the two shorter sides have to be 6 and 8. Now we have to check whether this is accurate and makes a right angle triangle. So to do that, you can maybe do it mentally, but let's do some working out just to make sure we understand it. So using Pythagoras, we have c squared is equal to a squared plus b squared. Okay, now c has to be, when I solve this, it has to equal 10. Okay, if it doesn't, then this can't be a right angle triangle. All right, so c squared, to imagine we don't know what it is just yet. We're going to check and see if it's 10. So that can be, 6 can be my A and 8 can be my B. So I've got 6 squared plus 8 squared. So C squared, is equal to 36 plus 64. C squared is equal to 100. And now let's square root it. So C is equal to the square root of 100. C equals 10. We can see we got our 10, which means that this is a right angle triangle. These numbers belong to a right angle triangle because when we work out the Pythagoras Theorem, 6 and 8, these two side lengths, when they are squared, give us the side length of 10. So that's correct. Okay, our next question asks us to find x approximately to 2 decimal places. So have a go first. Okay, for this question, I need to first figure out, am I going to be using Pythagoras or trigonometry? And if I have a look, I can see there is no angle, which is an indicator that I have to use Pythagoras. And I do have I have two sides given to me. There's a 17 here and a 13 there. So we have to use Pythagoras. Now your next step is identify the hypotenuse. So 17 is my hypotenuse. So 17 is C. And then I might say A can be 13 and B can be X. It's good to identify your variables so you don't make a mistake in your working out. And it's also clear to your teacher what you're doing. Okay, so let's write our formula. C squared is equal to A squared plus B squared. Now, if you already know how to do this without having to rearrange it, that's fine, the shortcut way. But we're going to do it the long way just to make sure we're okay. So C is now 17 squared. So be careful, it's 17's on this side. Equals A is 13 squared plus B, which is X squared. And we are trying to find X. Now at this stage, you can just rearrange it quickly. I'll do it step by step. So I like to have my X on the other side. So I'm just going to rewrite it. So 13 squared plus X squared equals 17 squared. My next step is, we'll just change the color, to get X by itself. So minus 13 squared, that cancels out, minus 13 squared. So X squared is equal to, and I can also evaluate these numbers. So 17 squared is 289 and 13 squared is 169. And then subtract these, so 289 take away 169. Leaves me with 120. So X squared is equal to 120. And the last step is to, of course, square root it, so it cancels out. So X is equal to 120 square root. But the answers, this is our exact answer. So if the question said leave it in exact form, we would stop there. But it said to round it off, I think, to 2 decimal places. So just put that into your calculator. The square root of 120, which gives us, so X is approximately 10.95. We weren't given any units, so we can just write it like that. Okay, for our next question, it asks us to find the value of the variables to 2 decimal places. Now you can see with this one, it's starting to look more complicated because we have composite shapes. Now don't stress when you see this on your test because they're actually really easy. And the trick is to first work out any sides you can with the information you have given to you. So if I have a look at my shape here, I can see that I have X, Z, and Y that I have to find. What can we find right now with the information that we have? So try that first. Okay, so I can see that, yes, there's a right angle triangle, and there's actually 2 right angle triangles. If it helps, break them up. We've got that smaller one, and then we've got, a bigger one sharing the same right angle triangle. Sorry, ignore that line. And now fill in what we can for each triangle. So I've got X here. This diagonal line here is 12 centimeters. From here to here, I can see I've got my 6 centimeters, and that is the smaller triangle. The larger one, I can see the base has a length of 22 centimeters because it went from there to there. My Z is the hypotenuse, and this side here is also X. Okay, so that's what I've got here. 2 triangles, I've separated them, they're both right angle, and now I'm going to see what can I find with this current information. The only thing I can find is my X from the smaller triangle. Because I've got a length of 12 here and a length of 6. So I can use Pythagoras because I've been given two sides. So your first step is to find x. Now once again, to find x, label your sides. 12 is my hypotenuse. I am calling it C. A can be x and B can be 6. Okay, so we know the formula is C squared is equal to A squared plus B squared. And you can do it like we did it before. Do it step by step if that's what works for you. I'm going to do it in a shorter way. I'm going to rearrange it now. Because C is 12, we know what the hypotenuse is. We have to solve for A. So I will have A squared already by itself is equal to C squared minus B squared. Okay? When you already have the hypotenuse, there has to be a takeaway there somewhere, a subtraction. Now, if that confuses you, you just do it step by step and you end up with the same thing. Okay, so that's a takeaway just there. Okay, let's fill in what we have. So A squared, A once again is x we're trying to find. C is 12 squared minus B, which is 6 squared. So substitute all the values in and let's solve for x. So 12 squared is equal to 144 take away 36. Which leaves us with 108. Square root the 108. Oops, sorry, that's gone. And the square root of 108 is approximately, to two decimal places, because the question asks us that, 10.39. Okay, we didn't round up because the number after the 9 was a 2. So remember, if it's 4 or less, it stays the same. If it's 5 or more, we would have had to add a 1 to the 9. Okay, so you stop there. So hopefully you had that for x. And now we can see, now that we have the x value, x over here is now, sorry, it just disappeared, 10.39. So x is 10.39 centimeters. I now have my value, oops, the whole triangle's gone, for x. Okay, so now I know what x is. X is 10.39. Can I work out what z is now? So try that. So let's work out z next. So z belongs to that larger triangle. So I'm going to redraw it again so I can see it more clearly. So x, remember, we found it. It is 10.39. So I've got 10.39 here now. Z is what I am trying to find. And the base of this bigger triangle is 22 centimeters. So down there you put 22 centimeters. We can see it clearly now. And we can see why we had to find x first. Without x, we couldn't find z. So, once again, this time I'm trying to find the hypotenuse. So z can be c, a can be 22, and b can be 10.39. So c squared is equal to a squared plus b squared. So c squared is equal to, a is 22 squared plus b, which is 10.39 squared. C squared is equal to, so put it into your calculator, we end up with 591.9521. If the decimal was any longer, you can just round it off here to two decimal places because the question does ask us that. Okay, so C is now equal to, get rid of the squared by square rooting it, so 591.9521, and the square root of that to two decimal places, we end up with C is equal to 24.33, and our units are centimeters. Okay, so we have now, so found Z. I forgot to replace C with Z, so that's fine. Just make sure in the final answer, Z is written there and it's equal to 24.33 centimeters. So if you like to keep C when you're working it out, that's fine. But just remember, in your final statement, you have to put the variable you found. Z is 24.33, so it's nice and clear. Some of you on the worksheets didn't do that. you kept C there or any other variable, and you forgot to say, okay, X is actually this and Z is actually this. So just remember to do that. Okay, so we have found Z, we have found X, and that just disappeared again. What is left? Our Y. Now have a look at at the information we have. Y isn't really part of Y itself. The base of it is from here to here, and this triangle here is not a right angle triangle. So we can't use Pythagoras for that, even though we know what Z is, because Y is not, it's not a right angle triangle. But do we have to actually use Pythagoras? No, because we have 6 centimeters given to us. We have from here to here. We have 22 given to us. So you can see that the bigger line, so 22, take away 6, will leave us with Y. So just to show some working out, we'll say Y is equal to 22 take away 6. Y is equal to 16. And don't forget to write centimeters. Okay? And we have found all 3 variables. The first one we had to find, or we could have found Y first, because Y didn't need Pythagoras. But we had to find X first and then the Z, because we couldn't find Z without X. So hopefully that was okay. Our next question asks us to find the exact value of X. We did one of these in class, and we had to revise some of our algebra skills. So we have to apply our algebra skills in this. So let's do this one together. Okay, so if you ever see a question like this, just do Pythagoras as you normally would. So the hypotenuse is 5, so C can be 5, A can be X, and B can be 2X. Okay, so I have my formula, C squared is equal to A squared plus B squared. So C is 5, so I have 5 squared is equal to A is X squared plus B is 2X. Now, this is where you have to be careful. If you just went 2X squared like that, you've actually made a mistake. And if you remember in class, I did say we must substitute with brackets. So we'll do that one again. So 5 squared is equal to, so technically I can put brackets around here. That I have to be there in this case for the 5, but we're using brackets for the rest. So A is X squared, and the square is just on the outside, plus, this is where it's really important. The 2X must go in brackets, and we must square it. Okay, otherwise we won't square the 2. So when it's in brackets, everything is being squared. The 2 and the X as well. Okay, and the same thing here. The X here and the 5 there. So I end up with 5 squared is equal to X squared plus 2 squared and X squared. So they all get squared each. Now square all the numbers that we have. So 5 squared is 25 equals X squared plus 2 squared is just 4, and then I have my X squared there. We don't know what X is, so we can't get a number for X. Now, if you notice, these here are like terms. I can add X squared with the 4X squared. We know there's an invisible 1 here, okay? So we have 25 is now equal to 1x squared plus 4x squared. 1 plus 4 is 5, and we write the x squared there. The x squared doesn't change, it's just saying we have 5 of those. If I continue it up here, now we have to solve for x, just like we normally do. So I am going to rewrite it, so my x is on the other side, so 5x squared is equal to 25, because I like my variables on that side. And my next step is to simply make x by itself. So divide by 5, divide by 5. So x squared is equal to 25 divided by 5 is just 5. Now square root it, and we're left with x is equal to the square root of 5. The question said to leave it in exact answer form, so we stop there. The square root of 5, is a third. That is a third. We don't get a whole number, so it's a never-ending decimal. So it's irrational, so we stop there. Okay, for our next question, it asks us to find x to one decimal place. Now, we have to work out whether we are going to use Pythagoras or trigonometry. I can see an angle, and there's 77 degrees there. So straight away, I know I can use trigonometry because there's an angle given to me, and one side. So let's work it out. Okay. So our first step is we're using trigonometry. We know we have to use one of these. So, toa. Please always write this down because a lot of you are making mistakes when I marked your work. Now, my next step is label the sides that have information. So, x is my hypotenuse. So, I'm using h. 40 is opposite the angle 77. So, O and h. O and h is sine. Now, please write the formula out. Sine and the angle is equal to opposite over hypotenuse. We can see it clearly now. Okay? X is h and O is 40. So, and my angle is 77. So, sine is equal, in brackets, has 77 there now, is equal to, opposite is 40 over h, which is x. Now, I can see I've got x on the bottom. Now, these are the hardest ones you will have because x is on the bottom. Now, we have been doing it step by step. So, like times by x on this side, that cancels out, and times by x on that side. I can show you a quicker way if you like. And the trick is just swap the x, and in this case, the sine 77. They just swap. But you can do it the long way if you're more comfortable with that. So just swap them, and we end up with x up here is equal to 40 divided by sine 77. Now put that into your calculator. So 40 divided by sine 77. And to one decimal place, we end up with 41.1 centimeters. Please don't forget your centimeters, your units, because you may lose marks. For our next question, it asks us to find the angle to the nearest degree. So in this case, we definitely have to use trigonometry, and we are finding an angle, which means we will be using that inverse button, the one that has that -1. Okay, so once again, identify the sides that have information there. So we've got hypotenuse at 37, there's 37 kilometers there. And there's my angle. 17 is adjacent to the angle. So I know that the cosine, has A and H. The other thing to check is, are your units the same? Both of them have kilometers, so that's fine. I don't have to change anything. On your test, you may see questions where you might have, for example, kilometers and meters. So keep an eye out for that. Okay, so we're using cosine. So write the formula so we can see it nice and clearly. So cosine and the angles there is equal to adjacent over hypotenuse. And I've labelled my sides. So let's fill it in what we've got. Now, we are trying to find theta. So that's our x. Is equal to, adjacent is 17 over hypotenuse, which is 37. Now, this is the part where you have to remember, when you're trying to find the angle, we have to write the inverse of the cosine. So the angle stays here. That is like our x now. So it's by itself on this side. Is equal to, now this is where you write the cosine to that -1, which is the inverse. And in big brackets, you put 17 over 37. Enter it into your calculator. You can just put 17 divided by 37 if you want to. So find the inverse button. And then 17 divided by 37 equals, so the calculator gives me 62.64776 and so on. Okay, now the question asks us to round it off to the nearest degree. So that means the nearest whole number. So I've got this is my whole number, 62. Before I just write 62, just check and see. The number after the 2 is a 6. Because it's 5 or more, I must add a 1 to that 2, or round up. So I have now 63, and don't forget to write that the degree symbol. So my angle here is approximately 63 degrees. So theta is equal to 63 degrees. Okay, our next question is actually on your worksheet that you got today. And we looked at the angle of depression and elevation. So if you have done it already, you can have a look at what you've written down and just mark it as we go. Okay, so just to recap, with angle of elevation and depression, if we have a person who is just looking straight ahead, that is a horizontal line. So when doing this, there has to be a horizontal line as your starting point. Now, if this person decides to look up, they have made an angle of elevation from the horizontal line to the point they are looking at, I guess, the angle they've made. So it's very important. If they decided to look down, so there's my horizontal line, so that's neutral, our starting point, and they look down, they have made an angle of depression. Okay? It's really important you understand how to locate the angle of elevation and depression. So always have the horizontal line as your starting point. Always draw it and then put the angle in between the horizontal line and the line that you've drawn in that shows where they're looking at. Okay, so it's very important to draw accurate diagrams when you have a problem. Otherwise, you won't work it out because it won't look right. So from the top of a building, remember in maths, buildings, trees, whatever, can just be a straight line. That's supposed to be straight, sorry. Okay, and that building is 202 meters high. So we'll just write 202 meters. And if you want to, you can just show that by just doing that. Of course, there's the ground there. So we always have the ground. And then there's a second building that's shorter. So I'll just do it down here. There's my second building. And it says that these buildings are 120 meters away from each other. Okay? Now, we haven't been given the height of the shorter building. So I don't know what that is yet. So if the shorter building, I can just call it X because I don't know how high it is. But from here to here, it's 120 meters. Okay, so we've got our taller building that's 202 meters high, our shorter building, which we don't know the height of, and the space between them is 120 meters. Now, the next thing we have to look at is, it tells us that the angle of depression, so we'll read it again, from the top of a building, 202 meters high, so the taller building, the angle of depression to another building, 120 meters away, is 25 degrees. Okay, so from this top part here, so my tall building, to this part here, my shorter building, there's an angle of depression of 25 degrees. Now, if you went like this first, so from that point, there's your diagonal line. I'm sorry, it's not straight. Be very careful not to put the angle of depression in here. That will be wrong. That's why always do your horizontal line first. That's our starting point. So the top of the building is over here. Then we go down to the next building at an angle of 25 degrees. So you should have had that. Okay, so far we've pretty much finished the diagram in terms of the information they've given us. It's important to put all the lengths and angles in there, but we know with trigonometry, we need to have a right angle triangle. Now, read the next question. It asks us how high is the second building to the nearest meter. So they want us to find how high this building is. What is X? Now, I'm going to just draw my right angle triangle because I can see where it's going to be. There it is. You may have had that already. Now, before we do anything, how are we supposed to find the height of a shorter building? Well, if I have the height of a tall building, and if I can find from here to here, I'll change my color. if I can find the height from here to here, I'll call that, just say, y. So from there to there, if I subtract that from 202 meters, it will give me x, the height of this building. So we have done a lot of questions like this, where we have a taller length minus a section that we find, and it gives us the length that we want, in this case x. So hopefully you can see that. So the taller building, take away, we're going to find y in a minute, will give us x. Now, with this right angle triangle, this 25 degrees is not inside the right angle triangle. And we learned that alternate angles are equal. So you can see that sort of z we have here. There's a z there. That means the angle down here is 25 degrees. Another way of looking at it, if that confuses you, is some people actually can see, if we just draw a right angle triangle here, they are the same right angle triangles. They are identical, okay? So you can say y is here, and 25 degrees is now inside a right angle triangle. If that confused you, then just ignore it. But I thought I would just show you that there's actually two ways, using alternate angles, or just drawing another right angle triangle above the other one. But it's up to you. I'm just going to use how we did it in class. I'm going to use this triangle here. But they are both the same, and they'll give you the same thing. Sorry, it just disappeared. Okay, so if it helps, draw the triangle separately. So I'll just clear the page. So you've got your diagram written down. Okay, so I've just separated my triangle that I'm going to be working with. If it helps, you can do that. Now, let's see. There's my right angle. So, whoops, it disappeared. Again. So, identify the sides that we have. Hypotenuse is nothing there. Opposite is my y. So, O is equal to y. And my adjacent is 120. So, A is equal to 120. I know that tan, TOA, has O and A. And my angle theta will be 25. So, write the formula. Tan 25 is equal to I should have wrote the formula first. But anyway, y over 120. Now, my variable's on top, so it's pretty straightforward. You can rearrange it or just do it like this. Times by 120, that cancels out. Times by 120. So y is equal to tan 25 times 120. Put that into your calculator. So y is equal to the nearest meter, because the question asks us to the nearest meter, equals to 56 meters. Now that is not the height of the shorter building. Okay, so remember our buildings, the taller one was 202 meters. From here to here, there was our triangle. We have now found 56 meters. So all you're going to do now to work out what the shorter building is, we called our shorter building x. So x is equal to 202 take away 56, which gives us 146 meters to the nearest meter. Now, it's important to write your final statement. So therefore, the shorter building has a height of 146 meters. And you can say to the nearest meter if you want to. Or you could have said approximately to the nearest meter. Because it's an application, please make sure you write your final statement explaining exactly what that x was, because we put x in ourselves. Now the last one we're going to do involves a question you have on one of those worksheets. The ones that we worked on with similar triangles. We ran out of time in class to go through this. And this is very important because it's similar to a test question, and it is actually tricky if we don't go through it. So if you have your sheet, can you please take it out? Even if you've done it, we'll just go through it and tick it off. Okay, let's read through the question. So a 1.5 meter pole casts a shadow 3 meters long, as shown. So we've got a diagram there. Find the height, which they're calling h, of a building that casts a 15-meter long shadow at the same time of the day. So we want to find the height of the building, and we're going to use h to represent the height. Now, A asks us a question. Can you use Pythagoras or trigonometry to calculate the height of the building? Explain why or why not. Now, if you have a look, how many triangles are there in the diagram? So let's do, we're going to do C now and draw the triangles separately with the measurements given to give us a clearer picture. So this is what you should have had when you separated the two triangles in that diagram. The smaller one, we have 1.5 meters as a height, and the base is 3 meters. The larger one, we have h for our height. We are trying to find h, the height of the taller building. So that's actually the taller building there. And 15 meters was that base they gave us. So that's what you should have had. And we can see now, to find h, we cannot use trigonometry or Pythagoras. There is not enough information in this larger triangle. All I have is a 15 over here, and that's it. I need at least an angle or another side to work out h. So my other option might be to use our knowledge on similar triangles, and maybe working out the scale factor. So keep that in mind. So for A, you should have said, no, we cannot, because there is not enough information. There is no angle or second side length. Now we've done C already. We've drawn the triangles separately. Now, are the two triangles similar triangles? What test proves this? So these two triangles are similar triangles because they both share the same angle down here, and they also have the same angles everywhere else. There's a right angle here, and we learned in class that when you have a triangle, so I'll just draw it on this. When you have a big triangle and you just draw some other triangles in there with vertical lines. So I have drawn, there's a smaller triangle there, a medium size and a larger size. They are all similar because they all share this angle here. They all share a right angle. And we know if two angles are the same, that means these angles are also going to be the same. And which they are. So the trick is, when you see diagrams like this, yes, all these triangles will be similar. So the test that proves this, you could have written AAA, angle, angle, angle. All the angles in these two triangles are similar, are all the same. So they are both similar triangles. So we've done this part, draw the two triangles separately. Now, this is the next step. Calculate the scale factor by using the corresponding bases. Make the smaller triangle the original object, since we are trying to find the height of the larger triangle. So let's do this now. Okay, so here are my two triangles now, separately. I can see it clearly. Now, the scale factor, if you remember, is equal to a length over another length, but it has to be the original. Okay? And because we're trying to find h, we're going to start with this smaller one because we already have the information there. Okay, so to work out the scale factor, the length, so first do the original. The original is 3. We're looking at the bases, because we have the bases on both of these triangles. So I could only use the bases. So 3 goes on the bottom, and then 15 goes on top. Okay, my original is 3, and then 15 is on top. And this equals 15 divided by 3 is 5. So that is my scale factor. So I can use that to work out h. If you remember, the corresponding side of h is 1.5. So all I got to do is go, okay, what is 1.5 times 5? So that is what h will equal to. So So 1.5 times 5 is equal to 7.5 in meters. And we have found the height of our building using similar triangles. So H is equal to 7.5 meters, which is the height of our building. And the last part tells us now, can you calculate the hypotenuse of the larger triangle using the information you have found? So if we have a look, we can see that there's my larger triangle. I couldn't find the hypotenuse because I didn't know what H was. Now that H is 7.5, okay, I can now work out C, my hypotenuse. The base is 15. This side is 7.5 meters. I can work out C. So you go ahead and do that because our lesson's gone for quite a long time. So hopefully that has made sense. So just in case, I'll start you off. So you have C squared is equal to 7.5 squared plus 15 squared. And you just work that out. So hopefully that's helped you with your test on Thursday. And I'll be in our classroom lunchtime on Thursday if you need any extra help. And we still have a study session for our first lesson. Thank you.